Okay, everyone, let's take a look at lesson 63 together. You should have your packets in front of you, and the first thing we're going to start off with is filling in definition, a little bit of a reminder. We've already covered this in a previous lesson. Today we're going to be talking about addition of vectors, so let's re-identify what a vector is. So a vector is simply a quantity that has both a magnitude and a direction. Let's fill that in. Quantity that has a magnitude and a direction. Okay, so if you remember, magnitude is simply the length. Okay, so that's like the distance, and we always use the hypotenuse for that when we're talking about vectors. And then the direction would be what the degree, the measure of the degree is. So let's go ahead and start off with an example. We're going to come back to the packet in just a moment, but I'm going to do an example here for you to start off with, and then we're going to put one into our packet, and then we are going to do the practice one together, and then you guys will be all set to go ahead and start working on your lesson. Alrighty, so let's go ahead and start this. So first of all, when we're adding vectors, we want to remember that one of the things that we do is we always break them up into components using sine and cosine for the angles. Okay, so what we're going to do here, first of all, we have this word problem. Let me go ahead and read it aloud. Flying arrow. It sounds like it's maybe a member of an Indian tribe. Flying arrow left the village and traveled 20 miles on a heading of 20 degrees. From this point, he traveled 40 miles on a heading of 210 degrees. How far from the village did he end up? All right, so this is going to be one of those situations. We can see we have both our magnitude and our direction. So let's go ahead and set up how this would look when we write that using the symbolic form that we've learned for polar coordinates. So we take our 20, which is our distance, which is going to be our hypotenuse measurement, and then 20 degrees. So we're going to do a graph plotting that as a polar coordinate, and then we're going to do the second one, which is 40 miles on a heading of 210 degrees, and we're going to write that one like this, 40 and 210 degrees. Okay? Now, in this, what we're going to actually solve here is we're going to find every direction that flying arrow traveled. So we're going to identify how far north he went, or south, or east, or west. Okay, and so let's go ahead and start with the very first vector here. So we have 20 and 20 degrees. So I'm just going to, I know that both of those are going to land in the first quadrant. So I'm just going to draw the first quadrant here. So remember, we find our 20-degree angle. We start at the x-axis. But what I want to do here, since we're talking direction, think about this. This is my x-axis and this is my y-axis. But this is going to be, since we're going to be heading over to the right, this is going to actually be an eastward direction. And then this axis is going to represent north. It's going upward. Okay, so let's go ahead and start. So we're going to take 20, we're going to start at the x-axis and we're going to go counterclockwise about 20 degrees. Whoops, that changed it into a straight line, about 20 degrees. And then we draw our line for our distance here. This is going to be 20 degrees in here. And our hypotenuse is also 20 in distance. And we are going to make this into a right triangle. As you recall, we always do that because in order to use our sine and cosine, which we always use sine and cosine, in order to do that, we need to be looking at a right triangle. Okay, so we're going to find the first thing, we're going to find sine, and that's always going to be opposite over hypotenuse. But in this case, okay, this is going to be our north right here. So opposite a 20-degree angle is going to be considered our north measurement, and then we'll put that over our hypotenuse. So let's go ahead and do that. So we're looking for sine 20 equals the n. Normally we put a u there, right, for up. So we're going to put an n, since it's representing a northward direction, over 20, which is the distance. And then we go ahead and solve for that. And when you put that into your calculator, you're going to end up with a north direction of approximately 6.8. Okay, and it's positive, right? So it's up. I'm going to put a positive up just as a reminder to us. All right, now we have to figure out the cosine of 20. And the cosine is always going to be our adjacent over the hypotenuse, or in this case, it's going to be our east over hypotenuse, right? Because the adjacent side of our right triangle is the east line, or the east side. So that's going to be east over 20. We go ahead and solve for that. And you're going to end up with an approximate measure of 18.8. Okay, and that's going to be a positive right direction, right? So both of those measurements are right. Going east is to the right and going north is going in a positive direction. Both of those are a positive direction. Okay, now let's put a big line right here to divide these two. So we're going to now make a graph. Now this one is going to be at 210 degrees on this right vector over here. So we know we're going to end up somewhere down in the third quadrant. So I'm just going to draw mine a little bit bigger on this side. And this would be our X and our Y axis. And we're going to go counterclockwise to about 210 degrees. So we're going to keep traveling. There's 90, 180. The middle of that would be 180, 45, like 220 something. So we only want to go to 210. So we're just going to, oops. Oh, my thing changed that. Hold on a second. There you go. Let me start again. About right here. It doesn't have to be exact, you know. And then we draw our line here. And then we are going to make this a right triangle. We always go up to the x-axis and make our right triangle. We'll go ahead and label the parts that we do know. So we know that this distance here is 40. Now I have to figure out this angle right in there. Okay, it's not a 210 degree angle in there. We have to make the angle's measurement is from the x-axis below. So in order to do that, we have to do a little bit of calculating here. So let's see. We would have 210, and we'll subtract 180 from that, and you're going to get 30. So this measurement of the angle in there is 30 degrees. Okay, so we're going to find sine 30, and we're also going to find cosine 30. And that's going to be, now let's look at the difference in the directions of our travel here. Okay, so we've gone to the left on the x-axis. So we've actually headed in a west direction here. So I'm going to put a W. And then we've headed in a south direction right here. So we're going to put an S here for west and south. So the cosine is going to be opposite the 30-degree angle over the hypotenuse, which is 40. And the opposite angle is south over 40. And we'll go ahead, whoops. That's not correct. I'm writing in the wrong place here. Sorry. Boop. Let's go back up here to sine. South over 40. And let's go ahead and solve for that. And you put that in your calculator. In the south direction, you've gone approximately 20. Be what you get in your calculator. And keep in mind that that is actually traveling, if I want to think about the up and right, that would have been a negative, right? We're heading negative right. I'm sorry, south. I'm sorry, negative up. I apologize. A negative up. Because it was actually heading down, so that would be a negative up. You go down, it's up, but it's negative, right? So it's kind of like one of those oxymoron kind of things. All right, now let's find the cosine of 30, and that's going to be adjacent over hypotenuse, which the adjacent side happens to be the west side over 40. And when you plunk all this in your calculator, you should end up with approximately 34.6. Okay, and that would be a negative right. Okay, so just so we put those in parentheses over here. All right, just to kind of help us, because now we're going to have to write these in rectangular form, which we've been doing. We're going to do that for each vector, and then we're going to add them together, because once we've added them together, now we can figure out east and west, north and south, how did he really travel? So let's take our information. Let me highlight what we're going to take. So we're going to grab this 6.8 up, 18.8 right for the first one. So let's go ahead and write that. So we're going to write, we should do the right one first. So we'll do 18.8 right plus 6.8 up. Okay, now I'm going to go do the same thing for the other one. We're going to grab this 20 and this 34.6. But before we do that, remember, they're actually negative. Okay, because remember how we indicated that. Let me go highlight those two. Right over here. They're heading, both of those are heading in negative directions. So we're going to write them as negatives. So from this first rectangular form that I wrote down here, we're going to put right underneath that the second set. So we're going to have 34, negative 34.6 right minus 20 up. And we're going to add those together. So when you do the math here, you're going to end up with negative 15.8 right minus 13.2 up. Now, what does that mean? So if you've gone in a negative direction that we call right and a negative direction that we call up, well, on a map, what directions does that indicate? Well, a negative right is to the left, and we've already said that if you're heading left on the map or on our coordinate plane up there, we were heading west, correct? And then a negative up is actually like heading down, so you would be heading south. So Flying Arrow actually ended up traveling 15.8 miles west and 13.2 miles south. See how that works? It's kind of fun, actually. All right, so that was starting off with a toughie because it was a word problem. We actually had to kind of translate that into north, south, east, and west to kind of figure out how this gentleman was traveling. Okay, now in your notes, I'm going to go back up here now to our packet, and I am going to, we're going to work through this example 1 together. So you're going to notice that we have two vectors given to us, and we're going to add those together. So we have 30 at 55 degrees and 10 at 170 degrees. So the first thing we're going to do on the left side, we already have these little coordinate planes partially drawn in, the part of the coordinate planes that we need. So in the first one, we're going to graph this vector, and then we're going to label it north, south, east, or west. And that's what these letters mean right here. Okay, so let's go ahead and do that. All right, so we're going to graph 30 at 55. So the first thing we do is we put our pencil on our x-axis, and we're going to travel counterclockwise about 55 degrees. Well, we know that 45 is about halfway to the y-axis, so we're not going to get quite to the y-axis, but we're going to go slightly over half, so maybe about right here. Okay, and we draw our line here. We can label this as a 55-degree angle inside here. And our distance is 30. That's our hypotenuse. And when you say hypotenuse, you say hypotenuse of what? Hypotenuse of this right triangle I'm about to draw. Okay, so there we are. We have that drawn. Now in step 2, we're going to find the measurement of the angle using sine, or find the sine of the angle. Sorry, I said that wrong. Find the sine of the angle. So we're going to find sine 55 Okay, so let's figure this out. So sine is, I'm going to write over here, so it's always opposite over hypotenuse. So let's go back up to the graph here and let's label each side. So the x-axis here, we're actually going to call that east. Anytime you head right on a map, you're heading east, and we're heading up here, so this is going to be north. All right, so when we do sine and we're looking for opposite over hypotenuse, opposite is the north side over our hypotenuse, which is 30. So let's go ahead and plug that in your calculator, see what you come up with, and I'm going to do the same. And we are going to have an approximate measure northward of 24.6 is what you should have gotten there. You can round it. And remember, this is positive up. I'm just going to put a U here. Now let's find the cosine of the angle. Cosine 55, and remember, this is ca, or adjacent over hypotenuse, or in this case, we know that the hypotenuse is 30, but what is the adjacent side? The adjacent side to the angle 55 degrees is the east side, so we'll call that E. Now let's solve for east. Put that in your calculator. You're going to get approximately, let's see, get 17.21. Okay, and this is also in a positive direction to the right, so we're just going to put that in parentheses here. Okay, the bottom step down here, number 4, we're going to be adding these vectors together by adding those like components, but we can go ahead and write the first rectangular form from this first part of our problem here. So let's go ahead and do that. We like to write the right side first, so we'll have 17.21 right plus 24.6 up. Okay, now let's go over to the right side and let's do our polar coordinate here. We're going to graph the vector and we're going to label this one north, south, east, or west, just like we did in the first one. We're going to go counterclockwise. Let's go ahead and label these axes though. We're going to have, now we're going to end up, let's see, we're going to go 170, so we're not going to make it quite to the third quadrant. We're going to land in the second quadrant. So let's go ahead and put north here, since we're going to be above the x-axis. We're going to be in a northward direction, and then we're going to be over in that second quadrant, and that's going to be west. Okay, so let's go ahead and start over here on the x-axis in the first quadrant, and we're going to go 170 degrees. So you're going to go almost all the way to that next side over here to the x-axis. Let's draw our distance here. Let's make our right triangle while I'm thinking of it, so we can get ready. Let's label our hypotenuse, which we know is 10. I'm going to go ahead and put north here, and actually I'm going to move this little W over underneath the triangle so I can see the sides there that I need to work with. Now we do have to figure out this other measurement right in here, because this is our angle in green. Okay, because remember, we're not going to use 170 in our sine and cosine calculations. We need to figure out that little green angle right in here. Okay, and it's kind of easy to know, because if you'd have kept going from 170, you'd have been at 180. So what's left there is a 10-degree angle. Okay, so let's find our sine of 10. And that's going to be opposite over hypotenuse. And the opposite side here is going to be the north. Isn't it kind of cool to see how you can actually use this stuff? Oops, and you're going to get an approximate answer. We'll put that in our calculator, 1.74. Okay, and you can see that it's in a positive direction. North is going up, so it's a positive U. That's what we're going to have here. So there's our first measurement. And then we're going to find cosine of 10. And that's going to be adjacent over hypotenuse. And the adjacent side here is going to be the west side over 10. And we'll get an approximate measure here of 9.85. Now west is heading on our coordinate plane up here. It's heading west. It's heading left. Our point is to the left. So we are going to consider this to be a negative right. So let's go ahead and take our measurements from our second vector and write that down below. So you're going to have a negative 9.85 r plus 1.74 u. And we're going to add these together. And when you add our like components here, you're going to end up with 7.36 r plus 26.34 u. And that is actually the answer to this problem right here. Okay, so that's how you do this. They're not so bad. Actually, I think they're a little bit fun. So we have a practice problem here. I actually typed this on here right out of the book, so you don't even have to open your book right yet to get the problem out. Let's go ahead and read this. I'm going to highlight some important information. So Tracker left the cabin and he traveled 25 miles on a heading of 20 degrees. And from this point, she went 50 miles on a heading of 215 degrees. How far from the cabin did she end up? So we're going to do the same thing like we did before. The first step we're going to do here is we're going to find the first vector. And the first vector, let's go ahead and write down what it is going to be oh, excuse me, goodness gracious. Okay, so the first vector is going to be 25 and 20. Okay. The second one here in a moment, we'll go ahead and write it in. Go ahead and get that taken out of here and put it into our little format. It's going to be 50 miles at a 215 degree measurement here. Okay, so let's go ahead and figure out our first vector. So we're going to draw a graph. We only really need the first quadrant. Doesn't have to be perfect. You can sketch it in there. We're going to go just 20 miles. That's not too awful far. And draw our line. I'm going to go ahead and make this into my right triangle right here, right now, while I'm thinking of it. I'm going to label my measurement of my angle, which here is 20 degrees. Let's see if I can expand this so I can fit it in. 20 degrees. And then our distance here is 25, which is our hypotenuse. And let's figure this out. So going upward would be north, and heading to the right would be east. Okay, you with me so far? Okay, good. Alrighty. Now let's find sine of 20, and then we're going to find cosine of 20. So sine of 20 is always going to be opposite over hypotenuse, which over here is our north side. So that's going to be north over 25. And that is going to be approximately 8.55. Please put that in your calculator and double check me. And then cosine of 20 is going to be adjacent over hypotenuse, right? And adjacent over hypotenuse is going to be the east side over 25. Let's solve for that. Put that in your calculator and let's see what you get. Approximately 23.49. Okay, so there's our first one figured out. All right, and I'm going to go over here and we're going to look at the third step. The third step is going to be where we write both of our vectors in rectangular form. So let's go ahead and write the first one now that we know it. And what did we say? Now they're both going to be positive because they're both in the first quadrant, right? So you're heading east and you're heading north, all in the first quadrant. So this one, your north is going to be a positive up or positive u, and this one's going to be a positive right. So let's go ahead and write that in rectangular form. So you're going to have 23.49 right plus 8.55 up. All right, now let's handle the second vector over here. Now the second vector, I can see it's going to go into the 215 degree range, which is going to be not quite into the fourth quadrant, right? And we're just passing the second quadrant. So we're going to end in the third quadrant here. So we're going to need to draw a complete coordinate plane going counterclockwise. We're going to head from here to 215. So I'm going to already in my mind kind of figure out where this is going to be. I'm going to go to 180, and then I'm going to go slightly past it to about right here, 215. Doesn't have to be perfect, you know. As long as you label it correctly with your measurements, you'll be safe. Okay, so I'm going to fill in here. We have a hypotenuse of 50. Now I do have to figure out this angle. I'm going to change its color here. In here, we have to figure out what the measure of that angle is in there. We know that from this x-axis, when we went counterclockwise, we made a full 215 degree swoop. But I'm only interested in that little green portion there. So how are we going to figure this out? So I'm going to take 215. I'll just come over here and do that. And we're going to subtract the 180 from it, and that should give us what is left. And that's going to give us 35 degrees. So I'm going to put that inside there. Okay. Now, if you want to check to make sure that's right, you can add 215 and 35. Oh, no, wait a minute. Is 35 correct? So, yeah, okay, we're okay. I think I was figuring something out wrong here. Okay, let's go back now. Actually, what you want to add is the 180 plus the 35. That would take you to that. That's what I was trying to do. So if you add these two together, it'll take you back to that 215. Anyway, so as not to confuse you, you guys are all pretty good about figuring out when you have that missing angle in there, what you need to do to figure that out. Okay, so we know that's 35 degrees now. So now we're prepared to start with our sine and cosine calculations. So we're going to find, the first thing is we're going to find our sine, 35, and then we'll come down here and we're going to do cosine of 35. So let's figure this out. So we have opposite over hypotenuse, but you know what we need to do is we need to label whether we're going east, west, north, or south. Well, we headed, our point over here is going to be to the left, which is heading in a west direction, and down, which is heading south. Okay, so when we're looking for opposite our 35 degree angle, we have our south side over our hypotenuse of 50. I'm sorry, 35. Yes, no, wait. Yes, 50. Okay, yeah, I'm getting tired now. All right, so 50. And let's solve for that. And when you put that in the calculator, you're going to wind up with 28.68. Heading in a southern direction, right? If you're going south, it's negative, heading down. And remember, that's going to be like your negative up or negative u. All right, now let's find cosine. Cosine is going to be adjacent, and our adjacent is our west side over our hypotenuse of 50. Now let's keep on going. Put that in your calculator. Let's make sure we come up with the same thing. You should get an approximate measure of 40.96. Okay, and that is going to also be in a negative direction, right? Because you're heading left or in a negative direction on that x-axis. So that would be a negative r. Now let's go write the rectangular form of that. So right, we have a negative 40.96, right, minus 28.68 up. Okay, now let's go ahead and add that, the same components together. And you're going to end up with, put that in your calculator and double check, negative 17.47 R minus 20.14 U. Okay, now that is the correct form for rectangular form, but now let's translate that into directions, like geographical directions, and that would be the last thing we would do here. So let's see how that works out. So let's round this 17.47. We'll call that 17.5 miles. So he's going 17, or she, I think this was about a girl, 17.5 miles. Which direction? If she's heading in a negative right, remember we said negative right is heading west. So she went 17.5 miles west, and she also is heading, what does this say here? Negative up, so she's heading south. So she's gone, we'll round that to 20 miles. We'll just call it 20. Close enough, right? Because 20.1 is about 20. And so there's how she traveled, and that would be your final answer. Okay, so that's what they're looking for. It's a lot of work. It's kind of fun. It's just a little bit detailed. So try those problems. You'll come across a couple in your lesson, I'm sure. And then, guys, listen, tomorrow is going to be, on Friday, is going to be a review. It'll be recorded. When you come back on Tuesday, there will be a test. You can have an index card, 3x5-inch index card. Take the time to write down anything you want on that card. That's what you can use during the test. You're not going to be able to use your packets. So when you come in, please don't ask to do that. If you have your card, that would be fantastico. You can use that. I hope you guys have a great weekend, and I will see you next Tuesday. All right, guys, thanks for watching.